Now that we've built our concept of a line, we're really going to go in and kind of refresh on all of those important details, all of the terminology, and then we're also going to go through another way we can come up with the equation of our line. So remember, when we're working with a linear equation, they have that form y equals mx plus b. Okay? The y and the x are variables, so those are going to change. Those are the coordinates that the line passes through. And this m, remember, is going to be our slope. That's equal to the rise, or how much it changes in the y, divided by the run. So if you have 2 points, you do the difference in the y values divided by the difference in the x values. And again, these come from the same point, and so do x1, y1. And then that value of b is that initial amount, but is also the y-intercept. Okay. This particular form, because we have these two components, the slope and this y-intercept, this form is called slope-intercept form. Okay. And then just to refresh on what intercept means, it's just the point where you're touching that particular axis. So the x-intercept is where the graph is going to touch the x-axis, which is the one that goes across. And then the y-intercept is where the graph touches the y-axis. Okay? So looking at these two photos, these are two different lines. You can see one is going downward versus one is going upward. So in this first one, this particular point is where we hit the x-axis. So this is our x-intercept, and we usually just use INT to abbreviate it. And then this higher point is where we hit the y-axis, so this is our y-intercept. And then this particular line has that form y equals mx plus b. The value of b is whatever value it hits here on that y-axis, okay? And then the other thing that's kind of special, or that you can know about this, because it's doing this decreasing where those values are getting smaller and smaller. Remember, that graph is falling as you're reading it from left to right. You can immediately know that this is going to have a negative slope. And the reason for that is if you look at the rise over the run's something we always consider positive, basically. The rise is downward and the run is in the positive x direction. Whereas over here on the right, it's going to be the exact opposite. So again, just to label, this one here would be the x-intercept, and then the one that has the vertical axis is the y-intercept. And whatever coordinate this is, say it's 0, 2, 2 would be your value of b in that slope-intercept form. So this still has the same equation, just the slope and the y-intercept are different. But here, because your graph is increasing, meaning it's climbing as you trace it from left to right, you can immediately tell that this one is going to have a positive slope. Okay? Because if I go ahead and I compare the rise and the run, if I pick any points, my run is still going to be to the right, which is positive, and then my y value is going positive. And same thing, positive, positive. So that ratio is going to be a positive quantity, okay? So if we're given the equation of a line, or if we're given the graph is much easier to pick off what the intercepts are and to be able to find the slope. But however, if I'm given the actual format of the line, the way I'm going to know these points is just to give an example here. If I'm touching the x-axis, I have no idea what the x-coordinate here is, but on the x-axis, the y-coordinate is going to be 0. So in order to find the x-intercept, in your equation, you're going to set y equal to 0 and solve for x. For the y-intercept, you're going to do the exact opposite thing, because if I look at this y-intercept, I have no idea what the y-coordinate is, but I know to be on the y-axis, my x has to equal 0. So for this one, we set x equal to 0 and solve for y. Okay. So let's try a couple examples. For the first one, we're going to find the coordinates of the x and y intercepts. We're going to state those intercepts as ordered pairs because, again, they are points. And then for each of these, we're also going to find the slope of the line. So starting with the first one, if I want to find those two intercepts, I'm going to go ahead and see where do they hit the x and y axis. And so this is our x-intercept. This is going to be our y. So I don't have an equation, but that's okay. We just use the graph to get the picture. So the coordinate where we hit the x-axis is at -2, and the y-coordinate there is going to be 0. For our y-intercept, my x is 0, and where I hit the y-axis is at -1. So these are our two intercepts. And again, they're points on the line, so we have to put them as coordinate pairs. Okay. Now to find the slope, I know I have a formula for here. I can do the difference in x values divided by the difference in y's, and I have the 2 points here. However, you can also just do the rise and the run. So if I consider these 2 points, the run here is going to be +2. And then my rise is I go down 1. So my rise is -1. So our slope m is the rise over the run, which is -1/2. Okay. Or if you want to do this the standard way, you can go through, because we know how to find the slope now. We do the difference in the y values, so that's -1 and 0. And then I have to do the difference in the x values, but I have to stay consistent. -1 is a y coordinate pair, so 0 is x. And then -2 is that x coordinate. So again, these two have to pair together, and these two have to pair together. So once you go through this, this is -1 in the top, and then in the bottom, the minus turns to a plus. So you get exactly the same thing, but just takes a little bit more effort. Okay. Now for B, we don't have the graph here, so I'm not as lucky. I don't know. I can't just look at a graph. I could graph this if I wanted, but that's not always the best to do by hand because it's really easy to make a mistake or not graph things to scale. So let's start by finding the x-intercept. And again, if I'm finding the x-intercept, that means I'm on the x-axis, so I'm going to set y equal to 0, the opposite variable. So in this equation, I set y equal to 0, and I need to figure out what value of x makes this true. Okay. So to solve this, we have to isolate our x. So we go ahead and add 8 to both sides to make these cancel. And that gives us 8 is equal to 4x. And then one last step, we've got to divide both sides by 4 to get x on its own. And that gives us 2 is our x value. Okay. But again, this, remember, said to state the coordinates of the x and y intercept. So my x coordinate is 2, my y coordinate is 0. So that is what we do to find the x-intercept. Now the y-intercept is thankfully much easier, and it's always going to be. You also really can just use the equation because remember it's y equals mx plus b. This value here is your y-intercept. But if you don't remember, it is the nice trick. You set the opposite variable equal to 0. So plugging that in, this will be 4 times 0 minus 8. 4 times 0 is 0. So 0 minus 8 is negative 8. So our y-coordinate is negative 8, and our x-coordinate is 0. But again, this I could have gotten just because it's in that slope-intercept form, y equals mx plus b. The y-intercept is negative 8. Okay. Now, for this one, it's a little bit easier to get the slope because it's in slope-intercept form. M is our value. So this is exactly our slope. M is 4. Okay. But if you didn't like that or remembering that, you know the formula. You have the x and y intercept. Go ahead and find the slope by looking at the difference in those values. So using these points instead, I'll go ahead and fill in 0, negative 8 for this first point because those have to belong together. The y is negative 8, the x is 0. And then we do 2, 0 as the other point. So the y-coordinate is 2, the x-coordinate, the y-coordinate is 0, the x-coordinate is 2. And so in the top, negative 8 minus 0 is negative 8. In the bottom, 0 minus 2 is negative 2. And if you do negative 8 divided by negative 2, it is indeed positive 4. Okay. So you still get exactly the same answer doing it any of these ways. So now let's try to graph a line given the slope and given the y-intercept. So I know the y-intercept, that's super helpful. So I'm going to go ahead and plot that. I have a y-intercept of positive 3. The problem is I have no other point here, but I do know it goes through 0, 3. However, I'm going to use this slope to my advantage. It's negative 2/3. It really doesn't matter where you put the negative, but it makes the most sense in the top. Okay. All this means is my rise is negative 2 and my run is positive 3. So utilizing that I already know a point, I'm going to go ahead and I'm going to use my rise and run to find another point. So my rise in this case is negative 2, so I would go down 2. And then my run is positive 3. And that gives me a second point on my line, which would have the coordinates 3, 1. Okay. And now that I have 2 points, I can go ahead and connect the dots. But you can also keep doing this. I can keep finding more. So the problem is if I go down 1 over 3, I don't have that drawn out here. So I can kind of do the opposite as well. If I go to the left, that's considered my negative. So I'm going to go up for my y-coordinate. So it's kind of like putting the minus sign down here instead and keeping the rise to be positive 2. You flip-flopped both of them because it's all a matter of perspective. But going from here, it would be down over. So you can get another point on your line, which would be negative 3, positive 4. And then you can do this as many times as you want. And of course, because I'm drawing by hand, you can see this is why hand drawing is not the best. It's not the easiest to get the most accurate lines. Okay, but this is a good representation of our line. And then really, I also can get my equation for this just to kind of show you. It's y equals mx plus b. Our value of m is negative 2/3. And our value of b is positive 3. So this is the equation of our line. Okay. Now let's try a different type of problem. So we're told a line passes through the point negative 3, 3 and has a slope of negative 7. We want to write the equation of the line in slope-intercept form, meaning we want to put it in that form y equals mx plus b. Okay. So I know on this that our value of m is negative 7, but if I look at this point, neither of these are 0. They're not any of my intercepts. So m is equal to negative 7, but we have no idea what b is. Okay. So I can kind of start to fill out my line. M is -7, so cool, I can do that part. But how do I figure out this value of B? Okay. So what I can actually do, I know that -3, +3 has to be a point on the line. So I'm going to go ahead and plug this in for my values of X and Y. And then utilizing that, B will be my only unknown, and I can solve for it. So we're going to use the point -3, 3. In the equation to find B. Okay. So our X coordinate is -3. Our Y coordinate is +3. So plugging that in, Y is equal to -7 times X plus B. So I've set up an equation now where B is my only unknown. So I just need to solve for this. So -7 times -3 is +21. And then I've got a single step. We subtract 21 from both sides to find B. 3 minus 21 is -18. So this is our value of B. So the equation of the line is Y equals -7X plus B. I don't really want to write plus -18. So we just do -7X minus 18. Okay. So this is one way we can go about finding our equation in the line. But we do have another way we can go about this. And this is by using a different form called point slope form. So what happens is if you know a line passes through the point x0, y0, and it has slope m, then the equation of the line is actually going to be the following. It still looks kind of similar to y equals mx plus b, but it's been rearranged a little bit. So on this side, we're going to do y minus the y coordinate of the point. And this is equal to m times x minus the x coordinate of the point it passes through. So all this does is it comes from the equation of our slope, because if I go ahead and divide both sides by x minus x0, because these are the same things over here, they cancel each other out, and that's exactly the equation for our slope, the difference in y values over the difference in x values. So it's really just a rearrangement of that, okay? So to kind of dissect this, the x and y here are those variables. Those are going to stay as the letters. Because these are going to be the different coordinates that it passes through. But this x0, y0 are going to be numbers. It is the fixed point that the line passes through that you're given. Okay. So just to show you, we're going to do exactly the same equation, but I'm going to show you we get the same thing using this point slope form. Okay. So again, a line passes through the point -3, 3 and has a slope of -7. We want to write the equation of the line in point slope form, and then we're going to verify it's exactly the same thing by just rearranging the equation. So going through my point slope form, we do y minus the y coordinate is equal to the slope times x minus the x coordinate. Our slope we know is -7, so that's what I'm going to replace by m. And then this point x0, y0, or x0, y0, we're going to use that -3, 3. Okay. So the y coordinate of our point is +3. The slope is -7. And the x coordinate is -3. And then just clean this up a tiny bit because I don't like that double set of parentheses. Minus minus turns to x plus 3, okay? So this form here is if we left it this way, this is point slope form. So if it asks for point slope form, writing it like this, perfectly fine. But to show it's exactly the same as the one we just did, we're going to solve for y to get this in the form y equals mx plus b. Okay. So just rewriting this first, so this way I can draw on it and show things. I want to just get mx. I don't want this parentheses attached. So I'm going to go ahead and distribute the -7 out. So this is y minus 3 is equal to -7x. And then you have to do -7 times 3. So I'm going to skip that extra step. When you distribute it out, it becomes a -21. And then to solve for y, we go ahead and add 3 to both sides, and we get y equals -7x minus 18, okay? Which is exactly the same equation we came back up with over here. So works identical, just a different approach, okay? This tends to be a little bit quicker, especially if it doesn't specifically tell you what form to put it in. This is a perfectly acceptable answer, but just pay close attention to your directions because it will specify a lot of times which version it wants. This is very easy to set up the equation of the line, but this is not very useful for graphing, which is why we like this slope-intercept form instead. Okay. So to tie this all together, let's do one last example. We'll make it as hard as we can. We know 2 points that it passes through. No idea what the slope is, no idea what an intercept is. But I want to find the equation of the line passing through these 2 points. Okay? So first and foremost, regardless of whether I use point slope or if I use the form y equals mx plus b, I've got to find my slope first. So we need to figure out what is our value of m. So going through m, we can go ahead and preset this up. We'll put our first point in the first slot. So our y value is 7. The x value corresponding to that is 1. And then luckily for this next one, both the x and y values are -2. So in the top, this becomes 7 plus 2. In the bottom, that minus minus also becomes a plus. So the top is 9, the bottom is 3. So when we divide this, we find out our slope is 3, okay? So I'm going to show you both ways so you can do either one. You'll get to the same result in the end. I'll start with point slope so you can see it actually is a little bit easier than using y equals mx plus b to start. So we have to do y minus the y coordinate is equal to the slope, which I know is 3, times x minus the x coordinate. And I can pick either one of these points. So between the two, I like the positive ones just a little bit more. So the y coordinate of the point is 7. The x coordinate is positive 1. Okay. If I left it like this, perfectly fine. But I can show you we can get this to slope-intercept form as well. If we distribute that 3 out, that would give us 3 times x. 3 times 1 is 3, so it gives us 3x minus 3. And then to solve for y, we just add 7 on both sides. And we get it in the form y equals mx plus b. Okay? So this is the nicest form for the equation of our line. But if you don't like this approach, we're going to use y equals mx plus b to solve for b first. Okay, so we know y is equal to 3x plus b. Now I'm going to use the 0.17 because, again, that's just a cleaner point to work with. So the y coordinate is 7, the x coordinate is 1, and we have no idea what b is. So 3 times 1 is 3. And then solving for b, we still end up with the same thing, that 4 is the value of the y-intercept. So the equation of our line is 3x plus 4. So both of these work, completely up to you what you do more consistently. However, you do have to know both forms. So you can't use one over the other every single time.